So there's one last technique that I want to go through in this section, which is called rationalizing substitutions. So this will be just a particular type of substitution that takes a rational expression as the function that we're substituting, and this particular kind of substitution will often be able to simplify our integral into a form that involves no radicals. So that's kind of the goal here, is by sometimes we can do this where we can substitute radical expression, substitute the entire radical expression to transform our integral into something that contains no radicals. So that's kind of the goal. So let's look at an example. So here we've got the square root of x plus 4 over x. So by taking, in this case, the entire radical expression, u equals to x plus square root of x plus 4, we can then hopefully transform this integral into something that involves no more radicals. But it may transform it into a rational expression that may require partial fractions to solve. So that's kind of why here we're considering it in our partial fraction section. And the nice thing is that when I take this entire radical to be my u, when I square both sides, we get rid of the square root. And now I can solve for x in terms of u very easily. So that gives me something that I can put in for x here. Right? So for instance here, this would give me x equals u squared minus 4. And in addition, you also notice that it kind of makes it easier to differentiate as well. If I differentiate both sides, on the left-hand side I get 2u du, and on the right-hand side I just get dx. And with that, now I have an expression in terms of u that I can substitute in for dx. So this integral, it now easily transforms into something that has no more x, but now is replaced with the variable u. So square root of x plus 4 becomes u. Dx becomes 2u du. And then x in the denominator becomes u squared minus 4. And let's see what we have now. So this is 2 integral of u squared over u squared minus 4. Now it no longer contains any radicals, but it looks to me like this might require some of the methods that we've discussed here about partial fractions. In fact, the first thing I notice is that it's an improper rational function, so we need to reduce using long division. So we'll do u squared divided by u squared minus 4. So u squared divided by u squared is 1. 1 multiplied by u squared minus 4. And then I subtract from above, gives me a remainder of 4. So this becomes 1 plus 4 over u squared minus 4. Now looking at u squared minus 4, I notice that factors into u minus 2, u plus 2. So we'll do partial fractions. So that'll be a over u minus 2 plus b over u plus 2. So here, let's do the partial fractions over here on the side. Okay, so we started with 4 over u minus 2 u plus 2 equals a over u minus 2 plus b over u plus 2. Clearing out the denominators, I get 4 equals a times u plus 2 plus b times u minus 2. If I substitute u equals 2 in there, I get 4 equals 4a. Right? This term becomes 0. So we get a is 1. If I substitute u equals negative 2 in there, I get 4 equals negative 4b, because this term is now 0, so we get b is negative 1. Okay, so now our partial fractions. We've got 2 times the integral of 1 plus 1 over u minus 2, right? We found a was 1, minus 1 over u plus 2. We found b was negative 1. And so now we're ready to integrate. This integrates pretty easily from here. We get 2 times the integral of 1 will be u plus ln of u minus 2 minus ln of u plus 2. Okay, and then one final thing, we could put the u back in. So let me see if I can squeeze that in up here. So we'll put the u back in here and here. And here. So then my final answer will be, let's see, square root of x plus 4. So here I'm going to write the final answer up here. So it'll be 2 times square root of x plus 4 plus ln of square root of x plus 4 minus 2 minus ln of the square root of x plus 4 plus 2. One thing I also notice is that these two logs are subtracted, so you can combine them together into a single log if you want. So this could be written as ln of square root of x plus 4 minus 2 over the square root of x plus 4 plus 2. This factor of 2 that would have been multiplied in front here, we can bring it in as a power of 2. Okay, so just another way that you could write the answer. Okay, so sorry, yeah, I shifted it up here since I ran out of room, but yeah, that kind of picks up from this step here. Right, to get here. Alrighty, so that's an example of rationalizing substitution. So we replace the radical expression to transform it into a rational expression.